In the previous lecture, as we were studying about the several methods for logically implementing a link in the message passing systems, we have discussed about direct or indirect communications, and we have also discussed the issue of naming, which is associated with direct or indirect communication. Now in this lecture, which is the third part of message passing systems, we will continue with the methods for logically implementing a link in message passing systems, and here we will be discussing about synchronous or asynchronous communication, and automatic or explicit buffering. And we will also see the issues related with these two features, which are synchronization and buffering. So let us get started and discuss about the synchronous or synchronous communication, and let us see the issue related with the synchronous or synchronous communication, which is synchronization. So talking about synchronization, communication between processes takes place through calls to send and receive primitives. And there are different design options for implementing each primitive. So we have already discussed about this, and we have already learned that in message passing systems, the communication between processes, they takes place using the send and receive primitives. And there are different design options for implementing each of these primitives. And this message passing, it may either be blocking or non-blocking, also known as synchronous and asynchronous. So the message passing between two processes, they may either be a blocking type or a non-blocking type, and this is also known as synchronous or asynchronous. The blocking type is known as a synchronous communication, and then the non-blocking is known as the asynchronous communication. So now let us see what is the meaning of this blocking or non-blocking, or synchronous and asynchronous, and let us see what are the features of this. So this blocking or non-blocking features, they can be present in the sending primitive as well as the receiving primitive. That means when a process is sending a message, it can be either of blocking or non-blocking type. And also when a process is receiving messages, then the receiving primitive also can be either of the blocking or non-blocking type. So let us see how do they differ from each other. So first of all, we have the blocking send. That means if the sending primitive is of a blocking type. So what does it mean? The sending process is blocked until the message is received by the receiving process or by the mailbox. So if the sending primitive is of a blocking type, that means the sending process is blocked until the message is received by the receiving process or by the mailbox. So when a sending process sends a message, then that sending process will be blocked until and unless the message that it sent is received either by the receiving process or by the mailbox. So until and unless the message is received, the sending process cannot do anything else. It is blocked, and it has to wait until and unless the message that it sent is received either by the receiving process or by the mailbox. So that is what we mean by this blocking send order, synchronous type. Now coming to the next we have non-blocking send. So in this non-blocking send, the sending process sends the message and resumes operation. So unlike the blocking send, in this non-blocking send, the sending process will send the message, and it does not have to wait for that message to be received by the receiver or the receiving process. So its only job is to send the message. And as soon as the message is sent, it can resume operation. That means the process will not have to wait, but it can resume its operation. That means whatever it was doing once the message has been sent, so it does not have to wait for the message to be received by the receiving process or by the mailbox. So that is what we mean by non-blocking send. So this non-blocking send is of the asynchronous type. So those were the difference between blocking and non-blocking send, which is associated with the send message primitive. So coming to the next one, we have the blocking receive, as we had the blocking send and non-blocking send. Similarly for the receiving primitive, also we have the blocking receive and an unblocking receive. So in blocking receive, the receiver blocks until a message is available. So if a process is implementing the receive primitive, then that process will be blocked until and unless a message is available. So when does a process implement a receiving primitive? It implements a receive primitive when it is going to receive a message from some process. So once it implements a receive primitive. It will be blocked until then, unless it receive the message, or until then, unless the message becomes available. So that is what we mean by blocking receive. And the next one is non-blocking receive. So this is just the opposite of this one. The receiver retrieves either a valid message or another. So in this non-blocking receive, the receiving process is not blocked until and unless it receives a message. It will retrieve a message if it is there, or it will receive a message if it is there or another. That means nothing. So the non-blocking receive does not block the receiver unless the receiver receive the message. This is the opposite of the blocking receive. So this will again be the synchronous type, and this non-blocking will be the asynchronous type. So those were the issues related with synchronous and asynchronous communication in message passing. And we have discussed about the synchronization issue. And here we have two types, which is the blocking sent or the blocking receive. And then we have the non-blocking sent and the non-blocking receive. Now, coming to the next method, which is automatic or explicit buffering. We have this issue of buffering related with this method. So let us see what is this issue related with the buffering and what are the kind of buffering that we have. So first of all, what is buffering? When communication is direct or indirect, messages exchanged by communicating processes reside in a temporary queue. So basically, such queues can be implemented in three ways. So whether our communication is of the direct type or the indirect type, when messages are sent from the sending process to the receiving process or either to the mailbox, these messages, they temporarily reside in a queue, which is a temporary queue. So this temporary queue is known as our buffer. So this is the place where the messages can reside once it is sent and before it is received by the receiving process. So that is what we call a buffer. And this buffering can be implemented in three ways. So let us see what are those three ways in which a buffer can be implemented. So first of all, we have something known as a zero capacity buffer. So let's see. What is this? The queue has a maximum length of 0. Thus the link cannot have any message waiting in it. In this case, the sender must block until the recipient receives the message. So in this kind of buffering, called zero capacity buffering, the queue has a maximum length of 0. So basically, this means that in this there cannot be anything that is waiting, or there is nothing that can be stored in this buffer. Only one message can pass at a time, and it acts like a path to which the message will pass from the sender to the receiver. So it says the link cannot have any messages waiting in it. So in a zero capacity buffer, we cannot have any messages waiting in it. We can have only one message that will be passing from the sender to the receiver. So in this case, the sender must block until the recipient receives the message. And why is this? When we talk about blocking send, we said that the sender will be blocked until and unless the receiver receives the message. And this has to be implemented in your zero capacity buffer. Why is that? That is because if the sender is not blocked, and after sending the first message, if it is not blocked, it will try to send the second message. And when the second message is sent, if the first message was not yet received by the receiving process, then the second message will have to wait in the queue. But in zero capacity buffer, nothing can be waiting in the queue. So we have to make sure that the sender must be blocked until and unless a receiver receives the message that is sent. So just remember that only one message can be sent at a time in this zero capacity buffer. So you may think that, why do we even call it a buffer? Because nothing can be stored in it. So it is a zero capacity buffer. Just keep that in mind. And it acts like a link to which just one message can pass at a time. So this is one kind of buffer that we have. Now the next kind of buffer or queue that we have is known as bounded capacity before queue. So let's see. What is this? So in this, the queue has finite length and does at most and messages can reside in it. So if the queue is not full when a new message is sent, the message is placed in the queue, and the sender can continue execution without waiting. The link capacity is finite, however. If the link is full, the sender must block until spaces available in the queue. So, what do we mean by this bounded capacity buffer is that this is a buffer in which messages can actually wait. There can be messages waiting in this queue, but it is bounded. The capacity is bounded. That means it has a finite length, and that means at most end messages can reside in this buffer at a time. Not more than. And alright, it is a finite buffer. So that is what we mean by bounded capacity. So here, if the buffer, or if this queue is not full, if there is still space in that buffer when a new message is sent, then the message will be placed in the queue, and the sender can continue execution without waiting. So visualize it in this way. It is a buffer which has a certain capacity. So if the buffer is not full, then the sender can keep sending messages until and unless the message becomes full. We don't have to block the sender until and unless the buffer becomes full. But when the buffer becomes full, what happens? The sender must block until spaces available in the queue. So at some point of time, this buffer will become full because it is of finite length. It is of bounded capacity. So when the buffer becomes full, at that time, the sender must be blocked so that some messages from the buffer can be retrieved by the receiver, and some space can be created in the buffer. And when new space is created in the buffer, at that time, the sending process can resume its operation of sending the messages. So that is what we mean by bounded capacity buffer. Now the last one that we have is known as unbounded capacity buffer or queue. So in this unbounded capacity buffalo queue, what happens? The queue link is potentially infinite, thus any number of messages can wait in it. The sender never blocks. So in this unbounded capacity buffer, the length of the queue is potentially infinite. That means any number of messages can wait in that queue. So by this, what can we have? We can have the sender to keep sending the messages, and it will never have to block or wait. Why is that? Because the buffer is so unlimited or infinite length. So the sender can keep sending the messages, and it never has to block. And the receiver can keep receiving or retrieving messages from the buffer as in when required. So the sending process will never have to be blocked in this because the buffer resort infinite length or unbounded capacity. So those were the kind of buffers that we have in this buffering. So now we have finished discussing about the synchronous or asynchronous communication, and we have discussed about the issue of synchronization, and we saw the non-blocking and blocking primitives, and also we have seen about automatic or explicit buffering, and we discuss about the issue of buffering, and we saw the kind of buffers that we have in order to implement this method. And in the previous lecture, we have also discussed about the direct or indirect communication and the issue of naming and how it can be used. So with that, we have completed the topic of message passing systems. So we discussed that must be a communication link between the two processes are communicating, and we discuss about several methods for logically implementing this link. So those were the things we discussed in the 3 parts of this message passing systems. So with that, I hope the topic of message passing systems are clear to you. Thank you for watching, and see you in the next one.